Greenland Ice Sheet shocker. Colossal floods, astounding aftermath revealed. A monumental flood has erupted through the Greenland Ice Sheet, leaving scientists in awe of the discoveries made in its wake. In 2014, an unexpected event unfolded when a concealed lake beneath the Greenland Ice Sheet began to drain dramatically. This sudden release of water was so powerful that it propelled a surge upwards, creating a crater nearly 1 kilometer deep in the ice. Over the course of just 10 days, an astonishing 90 million cubic meters of water gushed from the lake. To put this into perspective, this volume is roughly equivalent to the amount of water that would cascade over Niagara Falls for 9 hours at peak flow. This incident stands as one of the largest subglacial floods ever documented in Greenland. However, the true surprise came not from the flood itself, but from the aftermath. Researchers were astounded to find a staggering 300. This chaotic landscape featured massive ice blocks towering 25 meters high, alongside 6 square kilometers of ice that had been scoured clean. Remarkably, none of these features existed prior to the flood. In a recent study published in the journal Nature Geoscience, a team from Lancaster University has shed light on this extraordinary event, revealing insights not only about the flood itself, but also about how such phenomena could influence the ice sheet's response to future climate change. The study highlights that one of the most recently identified yet poorly understood aspects of Greenland's subglacial hydrological system is its network of active subglacial lakes. The 2014 drainage event provided a unique opportunity to explore this system further. Utilizing high-resolution surface models and data from multiple satellite sources, including NASA and the European Space Agency, the research team was able to analyze the lake and the flood event in remarkable detail. Lead author Dr. Jade Bowling noted, "When we first observed this, it was so unexpected that we initially thought there was a problem with our data. However, as we delved deeper into our analysis, it became evident that we were witnessing the aftermath of a massive flood of water escaping from beneath the ice. Traditionally, it was believed that meltwater flowed from the surface down to the bed and eventually out to the ocean. This event, however, demonstrated that water can also be forced upwards through the ice under pressure. Approximately 1 kilometer downstream from the collapsed basin, a new zone of fractures emerged in the ice surface, characterized by crevasses and uprooted ice blocks with a combined height of 40 meters. Further downstream, an area of about 6 square kilometers of the ice surface had been completely scoured clean. These observations suggest that a significant volume of water surged up through the ice at this location, flooding across the surface. Interestingly, the scientists were surprised to discover that the flood occurred in a region where previous models had predicted the ice was frozen at the bed. Given the presence of the lake, this assumption could not hold true. The researchers propose that the pressure-driven fracturing of ice along the bed may have created a pathway for the water to flow. Dr. Amber Leeson, an expert in ice sheet hydrology, remarked, "Our findings have surprised us in numerous ways. They have provided new and unexpected insights into how ice sheets can react to extreme inputs of surface meltwater. These findings raise critical questions about the accuracy of current models in predicting the behavior of the Greenland ice sheet in a warming climate. As global temperatures continue to rise, the likelihood of more meltwater events like this increases. Yet much remains to be understood about their implications for the future of our ice sheets." To learn more about this groundbreaking study, check out the article titled "Outburst of a Subglacial Flood from the Surface of the Greenland Ice Sheet." The top image showcases the outburst fracture zone, derived from satellite imagery captured on April 28, 2015. Credit CPOM, Lancaster University, Digital Globe Inc. 2015, provided by European Space Imaging. For more intriguing stories about the environment from around the globe, consider exploring the following. An epic expedition through Congo's swamp forests reveals an unexpected find deep beneath the ground. Scientists have uncovered an ancient deep-sea superhighway that spans the entire globe. Discover why 500 million-year-old animals unearthed in the Grand Canyon have excited evolution experts. Even at the edge of the world, the signs of global warming are unmistakable. Massive flooding under Greenland's ice sheet, a hidden crisis. Imagine a staggering 90 billion liters of water erupting through Greenland's ice sheet. And yet, this monumental event went largely unnoticed. This remarkable occurrence took place in 2014, when a significant accumulation of meltwater beneath the ice led to a powerful flood that surged upward, breaking through tens of meters of solid ice. This not only fractured the surface, but also released water into the open air, marking a groundbreaking moment in our understanding of Greenland's changing landscape. For the first time, scientists have documented this extraordinary phenomenon in Greenland, providing crucial insights into how the ice sheet is evolving as it continues to melt and contribute to rising sea levels. The implications of this event are profound, revealing the immense power and potential destructiveness of meltwater that resides beneath the ice sheet. Jade Bowling, a glaciologist from Lancaster University in the UK, emphasizes the significance of this discovery. The existence of subglacial lakes beneath the Greenland ice sheet is still a relatively recent finding, and our study highlights that there is still much to learn about their development and their impact on the ice sheet system. It is essential to understand how frequently these lakes drain and what consequences this has for the surrounding ice. Greenland's ice sheet is a massive expanse of ice that blankets most of the island, reaching thicknesses of over 3 kilometers, approximately 1.9 miles. This colossal ice mass holds an immense volume of water. If it were to melt completely, global sea levels could rise by an alarming 7.4 meters, 24 feet. Until recently, scientists struggled to visualize what lay beneath this thick layer of ice. However, advancements in technology, particularly the use of aircraft equipped with radar, have allowed researchers to map the intricate and dynamic environment hidden below the surface. These observations have revealed that liquid lakes are not only common beneath the ice sheet, but also fluctuate with the meltwater, sometimes causing the ice to bulge upward in a phenomenon known as water blisters. The discovery of a flood powerful enough to crack the ice is unprecedented. Bowling and her team uncovered evidence of this dramatic event by analyzing satellite data from 2014. They observed that over a span of just 10 days, from late July to early August, a region covering 2 square kilometers experienced a sudden drop in elevation of an astonishing 85 meters, equivalent to the height of a medium-sized skyscraper. Prior to this dramatic collapse, the area had been rising by about 10 to 15 meters as water accumulated and pushed the ice upward into a dome shape. The collapse occurred when approximately 90 million cubic meters of water rapidly drained away. About 1 kilometer downstream from the basin, the researchers noted even more unusual findings. Here, a large section of the ice had become heavily fractured, with massive ice boulders reaching heights of up to 25 meters scattered across the surface. Further downstream, a 6 square kilometer area of the ice sheet was left remarkably clean, as if scoured by a powerful force. Bowling recalls the initial surprise of her team. When we first encountered this data, it was so unexpected that we thought there might be an error. However, as we delved deeper into our analysis, it became evident that we were witnessing the aftermath of a significant flood of water escaping from beneath the ice. The fracture zone downstream from the basin is where the water burst forth, gushing out and sweeping away a vast area as it flowed across the surface. While previous studies have indicated that meltwater can move beneath the ice, this is the first documented instance of it breaking through the ice entirely. As Greenland continues to experience rapid melting, this information is crucial for understanding the future of the ice sheet. Amber Leeson, another glaciologist from Lancaster University, reflects on the findings. Our study has revealed many surprising aspects about how ice sheets respond to extreme inputs of surface meltwater. It underscores the necessity of comprehending the complex hydrological systems of the ice sheet, both now and in the future. Given the influence that subglacial hydrology has on the dynamics of the ice sheet, it is vital that we enhance our understanding of these hidden and poorly understood processes. And satellite observations play a key role in this endeavor. This research has been published in the esteemed journal Nature Geoscience, further contributing to our understanding of the intricate relationship between climate change and the dynamics of Greenland's ice sheet. What do you think about the implications of this discovery? Could this be a turning point in how we understand ice sheet dynamics? Share your thoughts in the comments.